All right, we are beginning our last topic on our unit on solving equations. And this last topic is going to be solving practical problems. So you'll write practical problems on the blanks for topic 7. And what practical problems means is basically word problems dealing with equations. So underneath this, just in parentheses, you'll write equation word problems so that you know what that means. Practical problems are their equation word problems that you would set up an equation and solve in order to solve the problem. So now you're going to flip the page till after we did our translations, and you're going to flip over to the back of that page, and you're going to glue in your notes page sideways. And at the top of your notes page, once it's glued in like this, you're going to write our unit number or topic number just like we have here. So SE7, so topic 7 in solving equations, and you can just write practical problems. On the side here to the left, we have it noted that it's equation word problems. So you can just write practical problems like you have written first on your divider. Then you're going to turn your notebook sideways so that we can work on these example problems. So each of these problems is set up where once we read the word problem, we're going to have to create a variable, and we're going to define it, meaning we're going to say what the variable is and what it represents. We will set up an equation and solve it, and then the answer written with our units would go in that last box. So question number 1, 331 students went on a field trip. 6 buses were filled and 7 students traveled in cars. How many students were in each bus? So when you pick apart these word problems, the first thing you want to do is figure out what you're solving for. And that's right here at the end where it says how many students were in each bus. Whatever it's asking you to solve for is your variable. So I'm going to use n to represent the number of students on each bus. So then I have to use the other information in the word problem to set up an equation. Once you have the equation set up, you would solve it like any other equation that we've solved so far. But figuring out how to go from the words to the equation is why we were practicing translations. So just kind of a key thing you want to focus on here when you're looking at these word problems is, since it's an equation, you want to figure out what the total is, because that's going to be generally on one side of your equal sign. And then you're going to figure out what goes together to create the total. So if 331 students went on the field trip, that's my total number of students going. So I'm going to circle that 331, and that is my total. So I know that whatever my other numbers are, they have to equal 331. So whatever my other numbers are and their operations have to total 331. So it says 6 buses were filled and 7 students traveled in cars. Well, we know 7 buses were filled, but we don't know how many students were on each bus. That's what our variable is. I'm sorry, 6 buses were filled, and we don't know how many students were on each bus, and we would have to use our variable to represent that. So 6 buses, so 6 times however many students are on each bus, which is my variable, and the 7 students that traveled in cars. so plus the 7 students in the cars, would give me the total of 331 students that went on the trip. At this point, I just have a 2-step equation to solve. So if I use the boo-boo method for this, I would start by boxing in my variable and what's with it. Draw my railroad tracks. I would want to get rid of the plus 7, so I would subtract 7 from both sides, and this cancels. Then I have 6n is equal to, and I would have to do 331 minus 7, and you can use Desmos for all of this, but I've already worked this out. So this would be 324. Then I would box in my variable again to get just the n by itself. And at this point, to get rid of the 6, which is being multiplied, I would divide by 6. And I would divide by 6 on both sides. That 6 cancels, and over here, when I do the math, that's what n would equal. So n is going to equal 324 divided by 6. Which when I work that out would give me 54. So n is equal to 54. So when I answer this over here with my units, how many students were in each bus, I don't just put n equals 54, I answer the question. 54 students were on each bus. Moving on to number 2, Aaliyah had $24 to spend on 7 pencils. After buying them, she had $10. How much did each pencil cost? So again, what I'm solving for is my variable. So you could use C for cost, P for pencil. I'm going to use P for the price or cost of the pencil. You could use X for all of these if you want. It is up to you what you want your variable to be. Alright, so I want to spot my total because again, I'm going to figure out what comes together to create my total. So she had $24 to spend. So if that's the amount of money that she had total, that's my total. So my other values and operations will come together to equal 24. So she spent the $24 on 7 pencils. And then she had $10. So 7 pencils, well, 7 times the price of the pencil, which we don't know. So you would represent that by writing 7p. Then if she had $7 left over after that, that would be a remaining $10. So 7 times the price of the pencil plus $10 would give her the 24 that she started with. So at this point, we can solve our equation. I would start by boxing in my variable and what's with it. I would get rid of the plus 10 by subtracting 10. That would cancel. So I'm left with 7p equals, and 24 minus 10 would give me 14. To solve for p, I would box in p, divide by 7, divide by 7, that cancels, and p would end up being equal to 14 divided by 7, which is 2. So now that I've solved for p, I can answer the question, how much did each pencil cost? So each pencil costs $2, or you can write $2 per pencil. Alright, we're going to move on to Daryl now. So Daryl rented a bike from Ted's bike shop. It cost $15 plus $10 per hour. If Daryl paid $39, then he rented the bike for how many hours? So what we're looking for is how many hours he rented the bike for. Then he rented the bike for how many hours. So that's going to be our variable. So again, you can pick what letter you want to use. I'm going to use H for the hours that he rented the bike. So then I need to look at where my total is and what creates that total. So it cost him $15 plus $8 per hour. And he paid $39. So that 39 is going to be my total in this case. So we're going to end up equaling 39. We have to see what is combined to create the 39. So $15 plus $8 per hour. So per is going to mean times in this case. So 15 plus 8H, or $8 times the number of hours. My variable is in the second term here, but that's completely fine. I would still start by boxing in my variable and what's with it and getting rid of the other stuff. So I would box in the 8H and draw my railroad tracks. To get rid of the 15, I would subtract 15 and subtract 15. This would cancel, so I have 8H equals, and 39 minus 15 would give me 24. So 8H equals 24. To solve for H at this point, I would box it in and divide both sides by 8 to get this to cancel. And H would equal whatever 24 divided by 8 is, and 24 divided by 8 is going to give you 3. So to answer that question, he rented the bike for how many hours? He rented the bike for 3 hours. Moving on to number 4. Sandy won 40 super bouncy balls playing horseshoes at her school's game night. Later, she gave 2 to each of her friends. She only has 8 remaining. How many friends does she have? So that last sentence is asking me to solve for basically my variable. So I'm solving for how many friends she has. So I am going to use F to represent her number of friends. And you can always just use the same variable if you want. I like to pick a variable that makes sense to me based on what I'm solving for. So F for friends. All right, I'm going to see if I can find the total. So I have a few different numbers here, but it says that she won 40 super bouncy balls playing horseshoes. So that is going to be her total number of items that she has. So that's going to be what everything is going to equal. So everything's going to have to total up to 40. Now what creates that 40? She gave 2 to each of her friends. And then she also has 8 remaining. So each is going to be multiplication here, just like per was multiplication in the last one. So 2 times the number of friends that she has. So we don't know how many friends she has. That's what we're solving for. So 2F plus whatever she had left over, which was the 8, to total 40. So then I can solve this equation. So I would start by boxing in my variable and what's with it. So the 2F, going to get rid of the plus 8 by subtracting 8 and doing that on both sides. So this would cancel. I'll be left with 2F equals, and 40 minus 8 would give you 32. So 2F equals 32. To solve for F at this point, I would box in my variable. I'd box in F, and to get F by itself, I would divide by 2 to get it to cancel on that left side. So F would be equal to whatever 32 divided by 2 is. which would be 16. So f is equal to 16. So then to answer the question, how many friends does she have? She has 16 friends. All right, and this last one. How old am I if 304 reduced by 2 times my age is 244? This one is set up a little bit differently. I'm not actually adding anything together here to get my total. In fact, I'm actually, if I were to translate this using our keywords we talked about with our translations, I see is here, so I know that this is what I'm focusing on with my equal sign. Instead of it being a total, we know that something is going to have to equal 244. So we have to figure out what our variable is to see what we're solving for and what the rest of this is going to be. So it asks, how old am I? That's essentially what I'm solving for. Instead of it being at the end, it's at the beginning of our question here. So I'm going to use m for my age, for my variable. So if I look at this, basically the way that it's written, I have 304 reduced by means subtraction, and 2 times multiplication. My age, which is my variable, is 244. So 304 reduced by 2 times my age, so minus 2 times my age, which is my variable m, equals 244. So this one uses subtraction. And instead of the total being at the end, you see is and the number that follows it. So this one's a little bit different from the other 4. Now at this point, I have an equation to solve, but you'll also notice that I'm subtracting my variable here. So you need to be careful. I want to rewrite this so that this is an addition problem. So if you want, you can just turn this into a plus sign and then throw your minus sign, your negative sign in front of the 2m. So 304 minus 2m is the same as 304 plus negative 2m. So this way, when I box in my variable and what's with it, I'm boxing in the negative 2m. And I'm getting rid of the 304. The 304 is being added with that. So you would subtract 304 from both sides to get this part by itself. So that would leave me with negative 2m is equal to, and 244 minus 304 would give you negative 60. So negative 2m is equal to negative 60. Box in just my variable at this point, and I'm going to divide by negative 2 in order to get the m by itself. So this cancels. So m is equal to negative 60 divided by negative 2. Well, negative divided by negative is a positive, and so 60 divided by 2 would be 30, and it would stay a positive 30. So m is equal to 30. Now to answer the question, what does that mean that m is equal to 30? I was asking for how old I am, so then you could write I am 30 years old. So just to summarize, what you need to do with any word problem is you have to create some type of a variable, and the variable is whatever you're solving for. You can pick what letter you want to use, or you can always use X if you want, whatever you prefer. Then use the skills that we've talked about with translations and our other word problems to figure out our keywords, what our operations are, whether something is positive or negative. Set up that equation and solve it the way that we've been solving our equations. Last step is to make sure to write your answer with your units so that you are actually answering the question.